this assessment, we're asked to predict the product of the reaction without it specifying whether substitution or elimination might occur. And so let's get started the way we always do, first by looking at the alkyl halide. We note that it is a secondary alkyl halide, and a secondary alkyl halide can do pretty much any of the substitution or elimination reactions. So SN1, SN2, E1, or E2 could possibly be favored here. Our base/nucleophile, sodium ethoxide, is a strong base, and so we're going to call it a strong base/nucleophile since we don't know whether it will do substitution or elimination yet. But whichever one it does, it's going to do either SN2 or E2. It's not going to wait around for a carbocation to form. Our ethanol is the polar protic solvent, most likely used as the solvent here because of the way we make sodium ethoxide. But as a polar protic solvent, we might expect a reaction to be SN1 or E1. Now, when we have a mixed bag of votes like this, the decision really comes down to the strength of the base/nucleophile and the idea that as a strong base, it's not going to wait around for a carbocation to form. So we're really looking here at SN2 or E2. Now, how do we make the decision between SN2 and E2? Well, at primary, it's most likely SN2. At tertiary, it's most likely E2. And here we are at secondary having to make that decision. At secondary, we're going to look at how strong of a base ethoxide is really. That is, would it want to be a nucleophile or does it want to grab a proton? And so that defining number, that cutoff number is at pKa 11. If we look at the pKa of ethanol, that pKa is 16. With a pKa of 16, which is greater than 11, we say that ethoxide would prefer to grab a proton as opposed to doing substitution. And so we're going to be doing an E2 reaction here. We're not done yet because we have two possible E2 reactions that we could do. Now, I'm going to redraw the molecule over here because normally when we do an E2 reaction, we want to make the most substituted alkene. But we can only make the most substituted alkene that arises from an anti and coplanar hydrogen and leaving group relationship. If we draw on the hydrogen that would be removed to make the most substituted alkene, we see that this proton and this chlorine are on the same side. And so that cannot undergo elimination in the E2 reaction. And so the hydrogen that would need to be removed is on the other carbon. There are two hydrogens on this, but it's specifically this one here. That's the one that ethoxide will remove because it's anti and coplanar to the leaving group. When we draw that mechanism, we see that the product we're going to get then is the less substituted, but the only one that is mechanistically able to form. This is the product of our reaction.